Welcome back to part 2 of our Alephium developer series. This series is meant to get you guys, while you could be a new developer or an experienced developer, it's meant to kind of give you a soft introduction or a little bit more once we get into the series, an intermediate introduction. But yeah, let's get into it, right? So we're in our VS Code right now, and we're just going to go to our folder that is for our stack real quick. So we're going to go to our stack because we need to have our stack initialized before we can even start to work on anything else, right? So the first thing that we're going to have to do is we're going to open up our Docker. So if you haven't already, you need to go into your Docker and at least open it up. The application itself just wants to be started. It doesn't actually need anything else besides that, right? You can start your actual DevNet in your Docker if you want to, but for the sake of simplicity, I'm going to be starting it in VS Code. So anyways, we're going to get our command for our Docker. We're going to enter it in here. This is the command that you will use to get into Docker, or at least start it. And as you can see, Docker has started and is creating its containers. To check on that progress, you can open up your Docker application, which should be down in where your applications are running. So whatever your bar is, left, right, top, down, center, middle, it'll be there, right? So we're going to wait for our Docker to fully start up, and what that looks like is when we see that, yep, there we go, bam, our Docker has fully compiled. We can see that because of this right here, as everything is healthy, started, right? You can even check out some of these useful resources right here. We're not going to do that. We're going to instead go over to our actual code file now, right? So we're going to head over to our code file, and this is where we ended off last video. We compiled our contracts, which was as simple as doing a npm run compile. When we did this compiled all the contracts that were in the contracts folder. It didn't compile anything that wasn't anywhere else, right? And it'll even compile contracts if they're within folders, as long as they're within the contracts folder, right? So as you can see here, we have a token contract that has been compiled here. We have a withdrawal contract, and that's not even really a contract, so I'm going to stop calling it a contract. It's a script, which is a subset of a contract function, is the best way that I can explain it. Looking at our contracts a little bit more depth, that's what today's video is about, is actually looking at contracts and building contracts and understanding a little bit of, how we can use these contracts to actually build something on the blockchain that is really, really neat and really, really cool. This is just the template. We're going to remove this, however, and we're going to build something a little bit different. For this contract, we're just going to build a simple token builder. It's not complicated. It's just, a token that's built. And for this instance, we're also going to delete our withdraw function. That is part of the old contract, which isn't going to be part of our new contract. Of course, to use the token builder, however, we need to actually be able to have the built-in classes to actually, use the token, right? So you can find that on the Alephium docs, and pretty much anything you need can be found on the Alephium docs. They're not totally up to par yet, but they are getting closer to that point. And I think within a very short time, we'll be at a point where we can really build some really cool stuff. And you can build cool stuff right now. It just takes a little bit more expertise to get to that point, right? Which is why I'm doing this video, right? So yeah, let me find the little thing that you guys need, because I don't remember it even off the top of my head. So the thing that you guys will need is the import std fungible token interface. This will allow you to build an actual token, right? The next step is to declare it as a contract. So you have a contract name, and we're just going to call this contract YouTube. Doesn't have to be simple, doesn't have to be complicated, you know, it can be whatever name you want the contract to be, right? But that's how you're going to refer to it now in your scripts. So the next setup is going to be declaring variables. So variables are important within any contract, and it's always going to be name then type. So I'll show you guys what that looks like. We should just move this over here just because that's how I prefer it. So for instance, there's going to be a symbol, or actually name, which will take the form of bytevec. There's going to be a symbol for the actual token, which will also take the form as bytevec. And before we go any farther, I'm going to explain what bytevec is. This thing should not be considered as scary in any sense of the way. It's actually a very, very easy term to understand. Basically, to make the blockchain more efficient, we're not using strings because that takes up, just makes the blockchain less efficient. But when you write your contract, which this isn't, the contract that you're writing here is really just a template for when you actually deploy it. So what you're writing here is, you know, they have those ad libs where you fill in you can fill in an adjective, a verb, stuff like that. What you're writing here is the sentence structure and the blanks. And then when you get to the deploy contract, we're going to be filling in some of those adjectives, verbs, nouns, anything that might be within that. So that just kind of summarizes kind of how it works, right? We're going to specify how many decimals we have. This can be a kind of the way that I would describe it is like a bigger integer, right? So it's not going to take the int type, but it is going to take a Ralph variant of that. Supply, obviously. And for now, I think that's all we're going to need. There are some required functions that you need here, such as the implements. We need an implement for the import, so that just looks as simple as this. Right, so that's what that looks like. And that gives us everything that we need as far as, you know, the contract goes, right? So the next thing that we're going to do is we're going to do kind of the fillers. So you're obviously going to have events. We'll talk about those at a later point. And there's also error codes. Those aren't super complex. They're really just meant to help you debug. And for lack of better, we're just going to do that. Sorry, I like my code a little bit cleaner. So yeah, we'll leave it like that for now. And then we have our public functions. So we need to set those to be accessible. So they are public functions to get supply, get symbol, get name, get decimals, you know, any other contract variables that we might have in there that we want to check or be able to return within an actual contract function. We're going to then want to use those. So I'll just get the symbols and stuff out of the way real quick. Those aren't really hard to get at all. Those are quite easy, actually. So I'll go over what that looks like a little bit. All right, so this is how we can see the symbols, right? And these are just basic functions. I'll even fill this one in. It's a public function that returns the token's total supply. So they're not hard. You have a public function, you have the name of the function that you are going to use to call within a potential contract function. Now this is confusing right now, but it'll make sense in like a few seconds, which is our next segue into actual contract functions, right? So contract functions will have a I want to say it's almost kind of like a comment above it, but it's really just telling us more about what the actual contract is. We get this, and we'll edit that as the time comes, but for now it's going to look like this. And we can just specify kind of like what we want it to look like, right? So we'll just call this token create, because that's all it does. It creates a token. And then we can write all our code in here in this function. Not hard, not complicated, but that's your basic layout for a contract to build a token, right? I'll see you guys in the next video for how you guys can, well, actually, let me go over a little bit of the syntax here. This has really got to be all lowercase, ideally. There are some syntax things that Ralph doesn't like, and will give you really, really weird errors for it sometimes. So just leave the contract functions to lowercase, or at least that's what I've found is the best syntaxing style. But we'll end that part of this episode here, as I want to talk next episode about more about these events and more about these error codes. But for now, I've explained the bytevex, the U256, simple contract structure. These are required functions. Depending on what you're implementing, your contract is going to have specific functions that it will require in order to actually compile. These are some of those functions that are specific to the create token. So in the next video, we'll talk more about what I had mentioned and potentially building out the actual contract, which is here itself, and not the functions that we can call from within the actual contract. Thanks, and I'll see you in the next one. Peace.